Okay, so in the previous video, we looked at definite integrals, and I mentioned that the value that we get from a definite integral actually represents an important characteristic, and that is the area under a curve. So if I was to draw this function here, and I integrate it with respect to 1 to 4, the value I get from this definite integral is actually going to be the area under this curve from 1 to 4. If I change the limits from 2 to 4, this is now going to be the area from the if you just imagine vertical lines, it's the area under the curve from 2 to 4, so this area here. If I integrated it with limits of -3 to 0, then it'll be this area here. So that's why definite integrals are so important, because it allows us to find this particular area. Let's look at an example. So let's say we have this example here with 3x plus 6 over x squared minus 5. And they want us to find the area. It's always going to be under the curve, so we can't find the area over the curve by integrating. We can just integrate this with respect to dx and put in the limits of 1 to 3. If you do this, I get 3x squared over 2 minus 6x to the power of minus 1 minus 5x. Limits 1 to 3, plugging it in will give me minus 7 over 2 minus 19 over 2, just 6. That's going to be the area under that particular part of the function. Okay, let's try another example. So in this case here, they want us to find the finite region of R bounded by the x-axis and the curve with the equation y is equal to minus x squared plus 2x plus 3. So initially, first things first, they haven't told us the limits, but let's go ahead and sketch this. So if I sketch it, then you can see the limits I need to find, or the area I need to find will be this area here, meaning that the limits will be from this point here and this point here. So I need to find these two limits first. This we can simply do by just equating it to 0, right? So if I do that, I get x is 3 and negative 1. So I'll have to integrate it with respect to dx from limits of minus 1 to 3. Let's go ahead and integrate. So if we do that, we'll get minus x cubed over 3 plus x squared plus 3x, limits minus 1 to 3. Plugging it in will give me 9 minus 5 over 3, 32 over 3. So the actual integrating part is not difficult. It's us having to understand what the limits have to be to find the appropriate area for the question. Now, let's say I have a function y is equal to minus x, x minus 3, x plus 3, and I want to find the finite area. So once again, let's sketch out this function. So it's going to look something like this, where it crosses the x-axis at minus 3, 0, and 3. So if I wanted to find these areas, what I would have to do is plug in the lower limit of minus 3 and the upper limit of 3. So let's go ahead and do that. If you do that, then what you actually end up with is minus 81 over 4 plus 81 over 2 minus 81 over 4 plus 81 over 2, which actually reduces to 0. The area becomes 0, which doesn't really make sense, right? And we know it has to be wrong. The reason being is because of the fact that the areas are either side of this x-axis. Now, the definite integral value we get is always going to be the area underneath the graph. So for this positive part, we're going to get this area here. However, for this graph underneath the function, underneath the x-axis, the area we end up is this area here, but we actually get a negative value for the definite integral value. So this area here is going to be negative, this area here is going to be positive, and because they're the same area value, the magnitudes, they cancel out to be equal to 0. So this is a very important moment we have to understand. Whenever the area goes from above the x-axis to below the x-axis, we actually have to split up the integral. So the way we do that is, well, this portion here, I actually have to integrate from minus 3 to 0. And this portion here, I integrate from 0 to 3. And what I do next is find the appropriate values, or the definite integrals. If I do, I get minus 81 over 4 for this area and 81 over 4 for this positive area. Now, an area can't be negative, so all you have to do is just get rid of the minus signs for the areas underneath the graph. You'll always get a negative sign. Just get rid of it when you integrate. And so what we do is 81 over 4 plus 81 over 4 gives me 81 over 2. That's very important. That's why I always recommend you guys sketching the function just to visualize, just to see if the area or if the graph goes from a positive side to a negative side, in which case we would have to split up the limits. Okay, so let's try this example here. So in part A, they want us to find the coordinates of A and B. I'm just going to tell you it's going to be 0, 2, and negative 3. But in part B, they want us to find the finite region bounded by the curve and the x-axis. So it's going to be this region here. We should notice straight away there's some areas underneath the x-axis and some areas above the x-axis, so we need to separate them separately. Let's call this area A1, let's call this area A2, so let's find them individually. For A1, the lower limit is going to be negative 3 to this upper limit of 0, and for A2, the lower limit is going to be 0 to 2. Now we've identified the two separate areas, we just have to integrate it and find the definite integral values for each one. So if I integrate it, I'll get minus x to the power 4 over 4 minus x cubed over 3 plus 3x squared. Plugging in the lower limit, or the first A1 area limits in, I'll get negative 63 over 4, which makes sense, right, because it's underneath the x-axis. And the upper, or the area above the x-axis, if I plug the limits in, I get 16 over 3. For the area underneath, just remember, get rid of the negative sign, so it's going to be 63 over 4 plus the A2 area, 16 over 3, which will give me 253 over 12. So the one key thing I want you guys to take away from this video is always sketch the graph and always split up the areas we want to find depending upon if it's above the x-axis or below the x-axis.